Good afternoon. We are waiting for 5 minutes for the remaining student connections. Okay, I think sufficient students are connected to a classroom. So we can continue our lecture. Welcome to all students in the online lecture series on the ERTOS. B computer students, we are having the electric 3, that is the embedded and real time operating system. And today's our topic is multiprocessor scheduling. In multiple or the multiprocessor scheduling, multiple CPUs are available and hence load sharing becomes possible. However, multiple processors scheduling is more complex as compared to single processor scheduling. In the multiprocessor scheduling, there are the cases when the processors are identical. That is also called the homogeneous. In terms of their functionality, we can use any processor available to run any process in the queue. While approaching to multiprocessor scheduling, one approach is when all the scheduling decisions and input-output processing are handled by a single processor, which is called the master. 1 minute. हाँ ना चालू आहे ना आणि मग आम्हाला कसं लेक्चर सुरू नाही झालं आम्ही जॉईन करतो आम्ही होत नाहीये जर त्याच्यावर होत नसेल ना तर मी ग्रुपवर टाकलंय का मग मी आपल्या स्टाफच्या याच्यावर पण टाकतो ते डायरेक्टली आय डी जरी टाकला तरी ते कनेक्ट होतो लिंक तुम्ही दिलेल्या लिंकवर पण जॉईन करतोय हा जर लिंकला होत नसेल ना तर डायरेक्ट आयडी मी आयडी प्रोव्हाइड करतो त्याच्यावरती डायरेक्ट कनेक्ट होतो मी टाकतो ग्रुप हो ग्रुपवर टाकलाय का मी ग्रुपवर आयडी हा ठीक आहे चेक करते चालेल ओके ओपन जरा okay sorry for interference multiprocessor scheduling in the approaches of multiprocessor scheduling. One approach is when all the scheduling is when all the scheduling discussed and input output processing are handled by a single processor, which is called the master server or the master server, and the other processors executed only the user code. This is a simple and the reduce the need of the data sharing. This entire scenario is called the asymmetric multiprocessing. Second approach is called as the symmetric multiprocessing, where each processor is self-scheduling. All processes may be common ready queue, or each processor may have its own private queue for the ready processes. Scheduling further by having a scheduler for each processor examine the ready queue and select the process to execute. 1 minute. We are having some requests. Students are requested to join directly for the classes. Don't send the request. And directly add the students. Don't send the request to add. The next point is processor infinity. The processor infinity means a processor has an infinity for the processor on which it currently runs. When a process run on the specific processor, there are the certain effects on the cache memory. The data most recently accessed by the processor populated the cache for the processor, and the results successively memory accessed by the processor are often satisfied in the cache memory. Now, if the processor migrates to another processor, the content of the cache memory must be invalidated for the first processor, and the cache for the second processor must be repopulated because 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 of the high cost of the invalidating and the repopulating cache, most of the semantic multiprocessing systems. We have seen already that multiprocessing having the two types, symmetric and asymmetric. Out of that, it having the symmetric multiprocessing system. There are the two types of processor affinity. One is the soft affinity, second one is the hard. when an operating system has a policy of attempting to keep process running on the same processor but not guaranteeing it will do so. And so this situation is also called as the soft affinity. While the second one is the hard affinity. It is hard affinity allow a process to specify a subnet of processors on which it may run. Some systems such as the Linux operating system or the Linux implementation soft system, but also provides some system called as the hard affinity that supports the this technology. For the multiprocessing, there are the more some important students having their mics on open your system. So please put your mics on mute. Next is the load balancing. The load balancing, which keeps the workload evenly distributed across the all processors in the symmetric processing system. Load balancing is necessary only on the systems where each processor has its own private queue of the process which are eligible. The load balancing is the unnecessary because one processor becomes ideal when load balancing it immediately extract a runnable process from the common run queue. On the symmetric multiprocessing, it is important to keep the workload balanced among all processors to full utilize the benefits of having more than one processor. There are the two general approaches for the load balancing, which is already been seen in the operating system, that is the SPOS, the third year. One is the push migration, and second one is the pull migration. Shortly, we can say that push migration is a task routinely check the load on each processor, and if it finds the imbalance, then it evenly distributes the load on each processor by moving the processor from overloaded to ideal or the less busy. Well, second is the migration. Pull migrations occur when and the ideal processor pulls a waiting task from the busy processors for the its execution. Next is the multi-core processors. Multi-core processors are mostly used for the multiprocessors or the multiple processors. In the multi-core processors, that is also known as the multiple processors, cores are placed on the same physical chip. Each core has a register set of the maintain its architecture state and thus appears to the operating system. Symmetric multiple processor systems that use multiple processors are faster and the consume less power than the systems in which each processor has its own physical chip. However, multi-core processors may complete the scheduling problem. When the processor access memory, then it spends significant amount of the time waiting for the data to become available. This situation is mostly called as the memory stall. It occurs for the various reasons such as the cache miss while it is accessing the data that is not in the cache. In such case, the processor can spend up to the 50% of its time waiting for the data to become available from the memory. To solve this problem, recently hardware design have the implemented multi-threaded processors code in which two or more hardware threads are assigned to each one. Therefore, if one thread stops while waiting for the beep, core can switch to another. There are the two ways to multi-thread a processor. One is the coarse grain multi-threading and fine grain multi-threading. In the coarse grain multi-threading, a thread executes on coarse grain multi-threading, a thread executes on a processor until a long latency event or the long latency waiting, such as the memory stall occurs because of the delay caused by the long latency. Processor must switch to another thread to begin execution. The cost of the switching between the threads is high as the instruction pipeline must be terminated before the other threads can begin execution on the processor's code. Once this new thread begin execution, it begins the pipeline with the instruction. Students are kindly requested to please don't leave the class and rejoin the class. Otherwise, I locked the class and then you can't join again the class. Number of students, I see that some students rapidly leave the class and then again send the request to join. So don't happen again. Next point is the virtualization and the training. In this type of the multiprocessor schedule, even a single CPU system acts like a multiple processors in a system with virtualization. The virtualization presents one or more virtual CPUs to each of the virtual machines running on the system and then schedules the use of physical CPU among the virtual machines. The most virtualized environments have one host operating system and many guest operating systems. The host operating system creates and manages the virtual machine. Each virtual machine has a guest operating system. Install an application run within the guest. Each guest operating system may be assigned for a specific use cases, applications, or the user, including time sharing for the real-time operations. Any guest operating system scheduling algorithm that has a certain amount of processing in a given amount of time will be negatively impacted by the virtualization. A time scheduling operating try to allot 100 milliseconds each time slice to give the user a reasonable response. 100 milliseconds time slice may take much more than the 100 milliseconds of virtual depending on how busy the system is. The time slice may take a second or more, which results in a very poor response time for the user in the virtual machine. The net effect of the such scheduling theory is that individual virtualization operating system receive only a portion of available CPU cycles. For the these multiprocessors or the multiple processors is we are having the real-time communication. And what is the real-time communication or the why is the real-time communication important or the what are the use of real-time communication we can see in the first one is the real-time communication. Why it is important? Real-time communication is important to consumers and business customers because in the wake of adoption of smartphones, they have come to experts immediately in customer service and information exchange. For example, a passenger who has missed a connecting flight may contact to reservation center for the asking the next connecting flight or the any other flight to reach the destination. In this use case, suppose in the customer will get the best service if the reservation center understands the contents of the passenger problems at the exact time of the contact. The agent should have already received the relevant flight update, saving the passengers from having to detail the situation one or more times will decrease the time to resolution as well as improve the customer's experience. That agent should have that and other passenger profile information at his disposal as well as where exactly in the world that traveler might be, down to the terminal and gate and to where he wants to get. Then, what is the use of real-time communication for the business? While the real-time communications may seem relatively new to consumers or the customers, in the business have used for the functionality for somewhat longer. For example, real-time communication has been available for years to companies in cloud communication messaging applications like Skype, HipChat, and other enterprise collaboration according to communication. Web-based flexibility is a part of appear of messaging platform. So user can have both real-time and near real-time options when it communicates with each other. And now voice communications have come into more common in the real-time communication apps, bypassing the traditional telephonic provisions. For example, in Mumbai, real-time rides hearing app and platform Greg goes over the top of unreliable local carrier infrastructure to communicate directly with the customers through voice message delivered via any voice API. Low latency, low low latency cloud communications network are used to communicate for this. Communication by using the real-time apps is unfined communications app with this enhanced capability and the capacity of the business and their workers time and money saving policy. Furthermore, business use cases for the real-time communication have now expanded into other commercial fields. For example, in workplaces without an office proper, for example, restaurants, retail stores, where the job description of the employee include being on their feet and on the go constantly. They can now use the real-time communications for the sorry they can use the real-time communications API or the real-time communication methods for the task coordinations, employee scheduling, work new and for example, if you go any restaurant, the waiter use the mobile app for the real-time communication to place the orders of the customers, which are directly placed to the kitchen and their shapes. Next is the what is the effect? What is the efforts or the what is the effect to make the real-time communication real? Since the early parts, every effort has been made to make the internet faster and faster. This led independent developers and research labs to innovate better and better technology in the world. But because of not everyone knew what others in the field were doing, incompatible solutions are resulted most. For real-time communications, they have the thought to avoid conflicting technologies through the standardization. In normal 2011, a joint efforts got underway by the Internet Engineering Task Force, that is the IETF, and the World Wide Web con- Consumptions, that is the W3C, to standardize a real-time communications across the internet according to the IEEE standards. These efforts includes supports for the protocols, API requirements, API designs, interconnecting the APIs, interworking with the legacy, VoIP, and the advancement in the conjunctions and flow control, as well as all over communications infrastructure. And so we can see that now we can use the IEEE standards infrastructure for the voice communication. These standardizations drive intend to enable all the interested sorry, these standardizations enable the interested parties to reach the consumer on a well-defined set of the protocols, and the API are developed for the real-time communications on their experience in the world of IEEE. That's way web developers, browsers, vendors, and the applications and the telecommunications provider can market in order to offer end users media rich web enabled products. What is the future of the real time communications? As we are use the real time communication, that is the online lecture is the best example of the real time communication. And so we can move from the traditional lectures methods to the online lectures, which are suitable for the teachers, students, and all the others also. The industry news, the side reports for the API and the communication platform as a service have the enable the online consumption model by connecting the various devices, machines, and the human for the mass exchange of the data. In these models, in these models, API serves as the kind of the digital currency, and by integrating the real-time communications directly into their application and business processes, companies can leave them for the efficient, reliable, and the secure transactions according to telecoms provider. Furthermore, IDC forecast that by enabling the voice, video, messaging via the APIs, real-time communications will easy solutions for the creation. In additional service integrated into the mobile apps, websites, and the business process will be become the simpler as the IDC sees that API powers real-time communications will enable underpricing and the outperformance of traditional communications solutions. Then we can see the what is the future. Then we can now see the what is the opportunities for the real-time communication developers. If we are working as real-time communication developers, that is the APIs and the other system developers, then all over real-time communications and strong appears among the developers, entrepreneurs, product managers, and the IT managers, in the opinion of some communication industry experts. That could be become they consider the real-time communication market to be a very large opportunity, while means it unconstrained and holds tremendous potential for the even the smaller enterprises as the 1 minute. Okay. Some students requested to increase the voice. My voice is hearable, or the how we can increase. Mm, maybe your mobile or laptop voice volume is low. Okay. ठीक है. This is the introduction of the real-time communication, which is useful for the multiprocessing. Now we can see what are the unsatisfactory approaches to the real-time communications. There are the several mechanisms for supporting the real-time communication which we consider to be unsatisfactory, in which one is the circuit switching. Circuit switching is very important mechanism used mostly in the communications, but which is now for the unsatisfactory for the real time. Why it is unsatisfactory? We can see that circuit switching for the instant can provide a real-time delivery guarantee very easily. A circuit switch network simply set aside a fixed portion of the network bandwidth according to the estimated peak bandwidth required for the each applications. As we will be discussed in the real-time traffic afterwards, it's offer the brushy leading to low effective bandwidth utilization unless the ideal time can be filled by the non-real time traffic. In addition, the typically cost guarantee of the bandwidth allocation can be lead to insufficient for the wide range of services expected to परत परत सांगणे काही स्टुडंट लेफ्ट होत आहेत काही प्रॉब्लेम असेल तर चॅट मध्ये मला टाका तो आय विल सॉल्व इट परंतु नंबर ऑफ टाइम्स तुम्ही जर लेफ्ट झाले आणि परत जॉईनिंगची रिक्वेस्ट आली तर इथं डिस्टर्बन्स क्लिअर होतोय circuit switching while the buffers at the received can be used to control the large bandwidth. The amount of buffer space required can be determined from the peak rate and delay of the delivered process and can be quite large for the network with no control delay. For example, if we can having a single video source transmitting 30 frames per second, each containing the 2 MB of the data, experiencing a transmission of the total frame within a 1 second would be required the 60 MB of buffered space at the destination to eliminate the jitter. On the other hand, the network can bound end-to-end jitter only by delaying the packets which required storage within the network. The trade-off between shared high-speed memory within the network versus the low-speed dedicated memory at the received need to consider. In the construct of the jitters guarantee, the delay guarantee cannot be provided by buffering alone, and so data may be lost in the transmission. And so circuit switching is mostly not used in the multiprocessors. Then goals for the real-time communications. All the methods of the real-time communications aim to provide a real-time message delivery within either low or the zero loss rates. The following are the some desirable properties of the real-time communications, that is the low jitter, low latency, ability to easy integrate non-real-time and real-time services, adaptable by dynamically changing network and the traffic conditions, good performance for the real network or the large network and large number of connections, modest buffer required within the network, high effective bandwidth utilization, low overhead in the header bits per packet or the cell, low processing overhead per packets within the network and at the end of the system. These are the some goals which are the we want to achieve in the real time communications. Then the characteristics of the real time communication. A wide range of the possible real-time communication applications are expected to coexist in a integrated network. A partial list includes multimedia, conferencing, shared workspace, remote medical diagnosis, telephony, commands and the control systems, and games and etc. Many of traffics or its source for which real-time services are desirable share the characteristics that set them apart from the traditional data traffic. We first focus on the general properties of the data rate, packet size, and the loss tolerance. We then summarize the work of the characteristics, the properties of the particular source of a real-time traffic. In the diagram or in the chart, we can see that first is for the data source, second one is the voice source, and third one is the compressed voice source. Again, the P or that is the packet size versus T, that is the packet intervals. Some real-time sources have inheritance characteristics that distinguish them from the typical data sources. For example, voice packets tends to be small to minimize the packet delay and to limit the effect of packet losses. The 48-byte cell size of the ATM, for example, was chosen primarily for benefits of voice applications to avoid the use of echo cancellation on the continuous conceptions. Also, small packets limits amounts of time a single packet can occur or occupied by the channel. In order to predict the performance of the communication system carrying the real-time data such as the audio or the video, an accurate source model has to be founded. This is the made difficult by the fact that statistics of the traffic entering the network depends on the nature of the source material, the encoding methods used and time packets by the encounters. Thus, model for the different time schedules are may be needed. The description of source is made easier by the fact that may real-time applications. One Many such sources can be approximated by one of the source models, such as the constant bit rate, second one is the variable bit rate, and third one is the periodic with variable packet size. Constant bit rate is the fixed size packets arrive at the destination determined intervals at the destination. Certain real-time applications such as the air traffic control generated data which has few redundancies and which is too important. The data is generated by the sensors at regular intervals. Variable bit rates is the source alternate between a period in which fixed size packets arrive with deterministic spacing and the ideal periods. The Periodic with variable packet size is each period the source submits a single packet of the variable to the network. The example is video, when the different frames may experience varying compressions ratios for the same output quality of that video. These are the characteristics of the real-time communications. Next is the hard RTC. We can see there are the two approaches of the real-time communications. One is the hard real-time communications, and second one is the soft real-time communications. First one is the hard real-time communication. Some real-time applications require a guaranteed maximum delay and cannot tolerate any packets loss. An example, consider a distribution process control system in which a message which indicate a reactor is about to exceed its pressure limits must be received in the time. Likewise, a response message which indicates the appropriate safety measures to take must be guaranteed a successful and timely delivered. A lost or the late message is either case could be a control controlling the watch traffic or the other reasons. The hard real-time applications are thus intolerance of the packet loss. The methods described in hard real-time communications are intended to provide the losses due to the buffers, overflows, and the mismatched deadlines. In our communication model, we can see on the screen the example of the network. The network is composed of the set of nodes connected by a set of links. Each directional links follow two nodes to communicate with the bandwidth. The set of links, that's the packets of communication or the connections, travels in going from its source to its destination is called as the path of that packet, and the number of hoops, that is the number of hoops in that path, is the set of the connection which is used a link. The example, two connections between the M1 following to the M2 path is ACCDD, and connection M2 following the path BCCDD for the link CD. Okay. For today's we are having the sufficient lecture. Remaining part will be continued in the next lecture of the online series. If students having any doubt, please ask, or please ping me on WhatsApp, or you can mail me, and I can solve your doubts. Okay then. Thank you very much for attending the online lecture series, and hope all the students are remaining present for the next lecture series. Thank you very much.